Tonight's talk, Steve's going to talk about the recent historic heat wave in Southeastern Australia. And the other thing I'll just mention is his forthcoming book, which is at the end of the description of tonight's event, Shifting Climate Zones, the Good, the Bad and the Ugly for Australia. So he may mention something about that. Okay, so will you please join me in welcoming Steve? You've got that one.
Thank you, RFB. Can you hear me okay? Okay. Yeah, thank you for that introduction. I think actually this might be the fourth presentation that I've given to the Society since I retired in 2016. Obviously gave the Thompson oration in 2017. And I think during the COVID time, I gave an online, when we resorted to online living, I gave a presentation, I think about waterways report cards.
That's right.
Yep. And that was, obviously it was important for us to keep informed during COVID while we were locked up in our homes or stuck at home. And I also spoke about climate change in Southeast Queensland and how we need to deal with it going forward. That was my third talk. So this is my fourth talk to the Society. So thank you for coming. Thanks for coming along. I would mention that the recent heat waves, we had a very hot January. Okay, so when I say, I mean the country did. And on a couple of occasions, we were the hottest place on earth in terms of temperatures that were recorded. And it's likely that some places where there weren't weather stations probably got into the low 50s for sure in the shade, but they're not verified temperatures. It's highly likely we did break the Australian record of 50.7, which I'll come to shortly. But it has to be broken in a verified weather station, not on grandma's back porch with a thermometer stuck on the wall that's getting the sun coming in on it. Often people say to me, I don't know, we had 60 degrees when I was a kid growing up in the 60s. And I said, no, you didn't. Not in the shade, not in a verified Stevenson screen. So when it comes to temperatures, we often get a lot of misinformation. These maximum temperatures are often, there's a lot of misinformation about them, and they should really be verified by the Bureau of Meteorology through their network, not from your own homemade weather station at home. Although if you've got a proper screen instrument, it's probably reasonably reliable, but if it's next to your driveway that's made out of asphalt, it's probably a bit dodgy. So really we're restricted to the Bureau network to make sure we're getting accurate readings. That aside, when human bodies are exposed to heat or wildlife or livestock, they don't really care whether it's 51 or 49. They're going to be in trouble. It will pose physiological discomfort to humans. So it's important that we learn from heat waves because we know they're going to become more frequent and more severe and also longer lived as we continue to warm the planet up. So there's some of the things I want to cover in this presentation. But I guess the catch cry for this talk is, should we name extreme heat waves like we name tropical cyclones? Now, there's a school of thought that says, yes, we should do that. There's another school of thought, including the World Meteorological Organization, that are a bit cautious about naming heat waves, and I'll cover some of that in my presentation. At the moment, we only name tropical cyclones the Bureau only name tropical cyclones in Australia. We don't name other extreme weather events. So, for example, if you go to the UK, they do name storms, these very severe extratropical cyclones they get sometimes in the North Sea or in the Icelandic lows, they're called. They can produce hurricane force winds, heavy rainfall, and they are given a name like Storm Bruce, whatever. So they do name storms just like we do tropical cyclones. Interestingly, we don't name East Coast lows in Australia, and historically they can be very destructive. So at the very end of my talk, I thought I'd have a little bit of, before the end, just talk a little bit about East Coast lows and why perhaps we should think about naming them as well. But of course, the focus is on heat waves. So I'll start off by just giving you a quick overview of trends in heat wave frequency and intensity in Australia. Again, going back to when records first became officially reliable around the year 1910. I'm also going to talk a bit of theory here about shifting baseline thermal climates. So when you change your baseline climate, what does this mean for things like heat waves? What does it mean for things like cold waves, the other end of the spectrum? Cold outbreaks versus hot outbreaks. I'm going to mention attribution studies because they've become a very popular part of the work of the IPCC and many research groups around the world. So I'll talk about attribution studies. I won't define it here, but we'll come to that shortly. I mentioned the Anthropocene because they're becoming more important because we're now living in the age of humans. Rather than just living in the Holocene, we're now living for the first time in a geological epoch that is entirely determined by the human imprint on the system. I'll talk about heat waves and public health because that's really where their greatest risk is. It's to humans, but it's also there a risk, as I said, to livestock, wildlife, and also to cropping systems in agriculturally important areas. For example, even if you're producing a high quality white wine or red wine, if you get a heat wave, it can destroy your vintage and you lose money. And I'm not the same as actually producing food, but nonetheless, it's an important commodity that we export. So I'll look at the pros and cons of naming extreme heat waves because as I said, there's two camps. I actually think we should name them because I think Australia is different, but I need to convince you of that. I've got some ideas about criteria for naming heat waves. At this stage, these are just my own ideas. I think they need to be worked through, but they're just some ideas to get the conversation started. I'll talk about the heat waves this year, which occurred earlier in the month of January and then towards the end of the month of January and extended into February. And I'll particularly focus on the second heat wave that lasted quite a long period of time. And I'll explain how it happened, if you like, its anatomy. So we'll do a bit of a dissection of that event to see what happened. What about future heat waves in Australia? If we continue on our current carbon emission pathways and we exceed the Paris targets of 1.5 and 2 degrees above pre-industrial, experts are now saying we're headed towards 2.7 above pre-industrial as we get into the 2090s. Not a problem for most of us in this room, but it will be for children and grandchildren who will still be very much alive. I'm looking at the younger man up the back. He might still be kicking around, but the rest of us won't be an issue, but it will be for our descendants. Dealing with future heat waves is what I'll finish off with. And finally, I just thought I'd talk very briefly, just one slide, have a bit of a think about why we should think about naming East Coast lows, not all of them, but those that meet certain criteria, just like we do with tropical cyclones. So what is happening in terms of trends in air and sea surface temperatures and heat waves? So every 2 years, the Bureau put out a state of the climate report, and that's available on their website, and they do this with CSIRO. So it's biennial. So the next one will be next year. And the World Meteorological Organization, they do a state of the climate report every year. And these are all available online. And although they can be a bit depressing to read, they are actually very important for people to have a look at these, even if you just look at the executive summary. So this shows that the graph on the left shows temperature anomalies. So this is where you're looking at comparing annual temperatures with some sort of what's called climatology baseline. And that's typically 1961 to 1990. So that's our baseline climate. And the zero line there that I've drawn a red line in through, that is when we've got below the zero line are negative anomalies. So that these are temperatures that were cooler than that long-term average from 1961 to 1990. And the ones above the zero line are positive anomalies. And you can see that they pretty well dominate in the more recent decades. We'd have no years cooler than the long-term average from about the 1970s onwards, 80s onwards, I think. Can't really see without my glasses here, just going from memory. The reason we get this up and down patterns, particularly so we've got land temperatures in orange, we've got sea temperatures in blue. The sea temperatures are a bit more smoothed out because the ocean has a different inertia with heat compared to the air. But the reason we get this variability from year to year is due to things like El Nino years, La Nina years. In fact, the El Nino La Nina is one of the main determinants of temperature variability around the world. We also get occasional volcanic eruptions. So if you look there, you might be able to see 1992, which was the eruption of Mount Pinatubo, where there was global cooling. Following that eruption, global, not just Australia, but applied globally. Nonetheless, the trend is generally upwards. We can see the 2019 El Nino there, which is that nice big peak on the orange. And then, of course, we've had a series of La Nina years, which are always cooler than average. And who knows what next year will deliver if we move into an El Nino. It will end up possibly well and truly exceeding the 2019 peak. So El Ninos, we tend to get warmer than average years globally. La Ninas, we get cooler than average. Someone said to me, can you explain why the Pacific Ocean has such a profound influence on global temperatures? And I think one of the most simple explanations that I have heard is when we have a La Nina, such as what we've had in recent years, we've got cold water pooling towards the coast of South America, and there's strong upwelling of cold water coming from deep, deep down, which is great for the anchovies because all the phytoplankton and the zooplankton is coming up from all the nutrients that have gone to the bottom of the ocean. They're being upwelled. It's nice cold water, it's full of nutrients. That food chain goes berserk, including the guano birds go berserk as well because they're eating the anchovies. The fishermen are happy over there in Peru. But that massive cold water acts like a giant natural air conditioner for the planet. Literally, it's an air conditioner on a grand scale. When we have El Nino, though, which is possibly what we're looking at by the end of the year, we're not 100% sure of that yet, that upwelling gets cut off because warm water sloshes across the Pacific from west to east and arrives there usually spring, early summertime, giving Southern Hemisphere analogy there. And that cuts off that upwelling cold water. The food chain collapses because there's no upwelling nutrients. There's no anchovies. The guano birds starve, and the fishermen don't have anchovies. And that's called El Nino. So, and you cut off that natural cooling effect. So it's a pretty well-known relationship between El Nino and La Nina and global temperatures. Most years, though, are neutral years. So they're neither La Nina nor El Nino, and that's when we get average global temperatures. Now, that's a natural driver of our climate system. But now we're throwing in another component. We're throwing in anthropogenic forcing of the climate system, which is due to these rising greenhouse gases from burning fossil fuels. That is adding additional greenhouse gases into the atmosphere. They're trapping the heat, and therefore that's why the graph is going upwards. But we still get variability with El Nino and La Nina cycles. They continue to be part of that natural variability. There's other things that can affect our variability, like the Indian Ocean dipole, the southern annular mode, and so on. But the El Nino La Nina is by far the biggest driver of not only temperatures, but also rainfall in Eastern Australia. So most of Eastern Australia is considered an El Nino hotspot. So when El Nino arrives, we know we can expect drought. We know we can expect bushfires. We can expect dust storms. And we can expect farming to really suffer, the need to destock and so on. And after we've had a series of very plentiful wet years with all these La Ninas and the odd weak El Nino, it could be a bit of a wake-up call this coming summer if we move into a strong El Nino, because there's going to be a lot of fuel out there for bushfire risk. And Brisbane is not immune to that by any means. It's not just the southeast of, because we're on the edge of where that can go right up into central Queensland. So that's something to keep in mind, but that's a little bit digressing a little bit from what I came to talk about. What this next graph shows is the number of days average temperatures were in the 1% of, I think that should say 1%, the warmest 1% of records. I left warmest out. You can see a clear trend there. You can also see 2019 standing out, which was an El Nino year when we had very hot, not large number of heat waves, plus of course the big fires down in the southeast. And we've had a bit of a drop off in heat waves with the La Nina years. But nonetheless, heat waves were quite infrequent. Despite the rhetoric out there, in the early 1900s, there weren't many at all, and they really started to take off from about the 1980s onwards. This is an Anthropocene signal here. We're finding there's an increase in the frequency and extremity of heat wave events. And this is set to get worse, but it's still set to vary between El Nino years and La Nina years. Now, we can sometimes get heat waves during La Nina years, ones we had in January this year. The La Nina hasn't gone away. It's gone away now, but back in January, we were still in a weak La Nina. It was very unusual to have the sort of heat waves we had during a La Nina phase. Way more likely during neutral or more so during El Nino. So this is another graph I wanted to show you. I'll have to turn sideways because I can't see this. What it's showing is we are shifting our baseline thermal climate. So just have a quick look at this graph. The dashed line is the previous climate. Remember, this is a theoretical model. It's not actually showing real data, schematic if you like. And our average temperature's gone up. Okay, so we've had almost 1.5 above pre-industrial. We actually breached that last year. Was it the year before, Michael? I think it was 2024. In between, yeah. And we've dropped a little bit, although this year won't be the warmest on record because we've had that La Nina effect, but it won't be long before we breach that permanently. Sometime in the early 2030s, we'll be permanently above 1.5. So even in La Nina years, it'll be more than 1.5. In El Ninos, it might be getting up to 1.8 above pre-industrial. So we've pretty well written off the lower Paris Agreement target. We've pretty well written that off. And even the upper target of 2 is now looking increasingly less likely. So we've shifted the temperature up. So this is the normal distribution of temperatures. Can you see how the new climate has moved upwards? So there's been a phase shift. And that means is at both ends of the normal distribution, we've got cold extremes on the lower end, which are cold. And on the right side, we've got more hot extremes. And the areas that have been shaded there, roughly before the original climate or previous climate, there was roughly equal number of cold extremes and equal number of hot extremes, which you'd expect in a stable climate. Okay, we still have variability from year to year, but overall the climate is stable. What we've done now is the new shaded area, which is a lighter blue, and you can see that we've actually increased, sorry, the lighter blue, we've got much less cold extremes for the new climate, which is the bold line, and we've got more hot extremes, which is the hot line. So that's just getting you thinking about sometimes it's the shift in the baseline that is the real problem rather than the extremes themselves. But what this means is as we go forward, hot extremes are going to become more common. We'll still get cold waves, cold outbreaks. They'll be much less common. We'll still break cold records, by the way, from time to time. That's particularly like in the Northern Hemisphere because the jet stream is becoming very wavy, so it's sucking really cold air down. So that's not such a problem. Well, it does occur in the Southern Hemisphere, but not to the same extent. So that's interesting. The second thing is we're increasing variance in our climate because of background global heating. So the curve for the new climate is flatter. So instead, in statistics, they call it platykurtic. Take me back to second year statistics. And leptokurtic is the more pointed distribution. So we made our curve flatter. We spread our climate. So that gives the impression, that means that with that idea, you get more cold extremes and more hot extremes because you flattened the curve, but you've kept your average climate the same. That's why the new climate and the previous climate still have the same mean. You just flattened it out. You just got more variability in your climate at both ends both tails. The lower one is we bring the two together. So we increase in the mean and the variance. So we shift the climate to the right, we drop it down to flatten it out. And what we end up with is a drop in cold extremes and a rapid increase in more hot extremes because of higher variance and also a shift in the baseline. So that lower one is the way we're tracking at the moment. And that will only get worse as time goes on, as we shift more and more to the right. And it's likely that variance will also increase further with global warming too. We'll get more extreme El Niños and more extreme La Niñas, both ends of the spectrum. So that's just a bit of sort of theory for you. I've covered that. If you like, the new normal is hotter with more hot extremes than cold extremes. So a lot of people are using this term, the new normal. Some people are saying it's actually the new abnormal. Take it either way you like, means the same thing. So attribution studies, very quickly about attribution studies. These weren't really mentioned in the earlier IPCC reports. Now, the first report was released in 1990. The most recent was 2021. It's now will be a significant hallmark of the next IPCC reports when they come out in a few years' time. Well, not too far away, actually. And the idea of an attribution study is you're really trying to quantify the human influence on the climate, how that is interacting with the natural variability of the climate system that we've always had, like El Niños, La Niñas, for example. So it says here, quantify the influence of human-caused climate change. This is mainly due to production of greenhouse gases on extreme weather events using peer-reviewed models and observational data to compare current climate conditions with a world without global warming. So that's your kind of baseline. Led by initiatives like the World Attribution Centre, you can go to their website and they put up case studies pretty well every month. So this latest one, it says record-shattering March temperature in the Western North America, which they've just had in their winter, virtually impossible without climate change. So the whole western part of the US has been stuck in this heat wave, this winter heat wave. Winter, I suppose, spring now, heat wave. The east has actually been quite cold, or sort of average to cold. So they cover heat waves, extreme rainfall, they cover tropical cyclones, they cover heat waves, droughts, just about every sort of extreme weather event you can think about gets picked up in there. Now, these attribution studies show that climate change increases the intensity and likelihood of many heat waves, floods, and droughts, assisting in risk assessment. And interestingly now, the lawyers have come into the fold. Climate litigation. People will hold governments, private sector to account for decisions they've made that did not take climate change into effect. This includes local governments with their planning. Climate litigation is be interesting for you to get someone in to talk about climate litigation. I think the society would be interested in that. They would be wearing a lawyer's hat, of course, but that is now becoming increasingly out there because of bad decisions made in the past that are impacting people today. Okay, so heat waves, we know they kill more people than other natural disasters combined. And we know there are certain vulnerable groups. I'm not looking around this room, but the cutoff age is around 65. And after 65, your body doesn't cope as well with heat waves. I know it varies from person to person, but apparently it's just because your body physiology changes. So Queensland, aging population, not only aging population, but already tropical or subtropical, so it's already hot anyway. Okay, Tasmania's got a bit more time to go, with this sort of thing. So that's important, but it's also infants and young children, pregnant mothers, breastfeeding mothers, disadvantaged groups, so socioeconomically disadvantaged groups that may not be able to afford air conditioning. And anybody with pre-existing medical conditions, so that could be younger people, but usually it's the older people. One of the reasons that they're vulnerable is because they've got comorbidities to deal with heat. And this is an issue globally. There was a big heat wave I think in France in 2003. I think it was 2003, Michael. Yeah. Paris was really badly hit. Now, Paris is a bit more like London. It's more of a temperate sort of climate, not like the south of France. And they weren't particularly geared up for that. A lot of places don't have air conditioning. They don't even have fans. It's quite a temperate climate. And it wasn't just Spain was affected as well. People did analysis of that, and they looked at the normal background death rate for that period of the heat wave and after the heat wave, and they calculated roughly 50,000 people died because of that heat wave. That was 50,000 people above what would normally have died in a population of that size, just normal births, deaths, etc. Now, if we look at some work here by Kebra, just based on based on a decade, about 36% of heat-related mortality in Brisbane, Sydney, and Melbourne was blamed on climate change in their study. And of course, they will affect human morbidity and mortality, and particularly in those vulnerable populations. That's work done. A lot of these are actually done by public health experts. They're not necessarily geographers. They're more on the public health side, but they do work with geographers and climate people, climate scientists. I mentioned the aging population. I think that is a big issue for areas of Queensland where there's a large cohort of aged population: Gold Coast, Sunshine Coast, Hervey Bay, Brisbane, obviously, but Brisbane's got a much bigger, younger cohort as well. Areas where you've got retirement villages, places like Bribie Island and places like that, they are quite exposed to this. And of course, what comes with heat waves, as we saw in 2019 and 20, is following heat waves, we often see bushfires. So we get that interaction. And it's only going to get worse, which means we have to think about adaptation, how we are going to adapt to heat waves in the future to reduce vulnerability in those particular population groups. Now, this is something I just came across the other day, although it was published a little while ago. It's kind of experimental data where they looked at temperature and humidity. So this is what I think is particularly in Queensland. We can often get heat waves where we get a combination of very high shade temperatures, but also high relative humidity. Where if you live in Melbourne, if you get a 42, or Adelaide, you get a 42 or 43 degree day, the relative humidity will probably be very low. And you can cope with that a lot better. You still have to be hydrated, but you can still die, of course. But when you have the combination of the two, it can actually be quite deadly. And that's why it's called the heat index. It's used by the Bureau and other groups around the world. This is where you combine temperature and relative humidity. And this is just a study of two different age cohorts. I mentioned 65. If you're over 65 like me, well, you're on the right. Young fella up the back. All right. Yeah, he's on the left. Who else is on the left? No one else?
We're the 18.
What?
We're the 18 side.
Yeah, right, okay. Can I see some ID? So this was looking at full sun, 6-hour exposure, and what is survivable and not survivable. So you can see that even with relatively low temperatures in the younger cohort here of 35, if it's combined with very high humidity, it's actually becomes non-survivable. And obviously with lower humidity, that's why there's that kink in the curve. Notice on the right, though, it's pretty grim if you're older. You don't have that ability to handle heat so well. The second one is probably a bit more realistic because you probably won't be sitting out in the sun for 6 hours full sun unless you're forced to work outside or something. You're more likely to be in shade. Nonetheless, it's still, when you're getting into these higher temperatures, which will become more common in the future, temperatures into the high 40s, low 50s will become, from mid-century onwards, will become most common most summers. And I don't mean out in the middle of the Pilbara. I mean Western Sydney, places like that, inland, particularly inland a bit. And you can see once again, it's even given some shade, it still becomes a killer. It's also a killer for wildlife as well. So the 2018 heat wave in Cairns, we were living in Cairns then. We had 42.5 2 days in a row, both at the airport and the Cairns racecourse. So 2 weather stations confirmed 42.5. Humidity, though, was actually in the 50s. So the heat index was actually nudging 50. The actual, what it feels like temperature, not the actual temperature, what it feels like, because the humidity was closer to 50. I don't know how many people died in that. Some people did, but 80% of the spectacle flying fox population was written off by that one heatwave event. It went from being endangered, well, it should be critically endangered, so it went from vulnerable to endangered just because of a 2-day heat wave. Right up there, up in Cairns. Yeah. Well, that was one of the camps. Yeah. But there you go. So wildlife is there, and obviously livestock as well. So what made me get to write about naming heat waves? Well, I collaborated with a doctoral candidate called Samuel Cornell. When I actually met him, I said, "How old was your photo?" He said, "I was taken quite a few years ago." So he's a more mature age PhD student, but he's actually with public health and community medicine at UNSW Sydney. So he's not a geographer. He's interested in communication of extreme weather events. So he's interested in climate and weather, but he's interested from a public health perspective. So he approached me because he was looking for a co-author, and the conversation suggested he worked with me on this article. So I'd like to acknowledge Sam's input to the next couple of slides. So I will also point out that we're not the first people to suggest this by any means. If you go back and do a Google Scholar search on this, people have been saying this for some time, other academics as well. It just hasn't got much traction at all. So we just sort of reinvented something that's already been out there a little bit. But it got a lot of interest, this article. Not a lot of reads necessarily, but it got a lot of interest in terms of media anyway. So one of the arguments here is I'm now moving very much more into psychology, behavioral psychology. There's not really a lot of geography in this, but it's a good example of how disciplines can work together. The power of a name. So here's a conversation article from the Conversation UK. Storm Doris. I told you they gave them names. Doris is such a lovely English name, isn't it? I keep thinking of an auntie called Doris. Storm Doris. Giving dangerous weather a human name makes us more wary, says research. Now, this is a storm. It's not a heat wave. This is just showing what it can be used for other kinds of weather events. It seems to work very well with storms because they're discrete entities like cyclones. They've got different intensities. It's a hurricane force winds, storm force. We know how fast they're moving, how much rain, how the area they're covering. So they've got discrete parameters, and giving them a name makes it more memorable to people. Like, I think living in the north, people do respond to cyclone names even after the event. They still remember that event. If it was just called Tropical Cyclone XYZ, you wouldn't remember it. So, and this is another example of an academic paper in the Journal of Risk Research looking at the impact of hazard naming, wireless emergency alerts, enhanced protected area decision-making, organisational studies. So focusing on wireless emergency, which often is what that's all they have if they're not able to get on the internet. So the thing about the name is names can make natural hazards more memorable. It certainly works for cyclones. And the United Kingdom's Met Office found named storms generate heightened media engagement and public awareness. People were quicker to secure property, cancel travel, and heed official advice, just like they do for tropical cyclones. So there you go, no great surprises there. We don't name these extratropical storms or East Coast lows, which are another form. Well, they can be hybrids as well. We don't give them names, but they do sometimes hit parts of southern Australia and even eastern Australia. In contrast, events described only by technical labels, such as intense low pressure system or a prolonged heat event, may not capture public attention as well. So I think we've all got names. We don't walk around saying this is my date of birth. So, you know, that's how you remember people. Names are quite powerful. Why not use it for extreme weather? So why should we name heat waves? We know that it improves public safety, and there was the Spanish tried this, their bureau equivalent, and they had heatwave Zoe back in 2024, which had a big impact, I believe, on Seville. Is that where they grow oranges?
Yeah.
Yes. But it was quite over large areas of southern Spain. So it showed that people remember the event's name were more likely to take precautions, like staying indoors and checking out vulnerable neighbours. So that's got to be valuable, because sometimes it's those vulnerable neighbours who end up dying in heat waves because they might be dehydrated, they might be disorientated, they may not have air conditioning. You invite them into your home, look after them. It also enhanced communication. So naming makes these abstract hot spells more memorable, helping the media report on them and allowing the public to better recall safety warnings. And this study showed that it was important for communication. Also, it drives urgency. Experts believe names would trigger a psychological gear shift. Again, this is from people who work in this field, not myself, prompting people to plan for heat risk as they would for a severe storm or tropical cyclone. You often get some idea that these heat waves are coming several days in advance, especially with modern forecasting. Would have been problematic many years ago. You wouldn't have been able to do that. There weren't the computer models. You hold the polluters accountable. So you might know the independent MP Monique Ryan, who is she's the member for Kooyong, that very nice blue ribbon electorate in Melbourne. There's always been a Liberal electorate since it was formed. Well, she is a teal independent. Dr. Monique Ryan, she's actually I think she's a surgeon, paediatric surgeon, before she became an MP. Now, her office contacted Sam and I and asked to have a bit of a chat about our article. So we did a video conference, not with Monique. She was in Canberra, but with her chief of staff. And she's since taken this to Parliament. I don't think it went very far, because I think she took it a bit too far. She suggested we should name heat waves after the polluters. So we'd have, for example, and we'd also have a different category system, which I kind of agree with. I think the current Bureau system of the categories, we need something more like cyclones, 1 to 5 system. So, for example, Category 4 heatwave Santos, or Category 3 heatwave BHP, whatever you want to call it. And that's where we drew the line and said we weren't going to go down that rabbit hole. We wanted just to see these systems named as per cyclones, alternating male-female names, and maybe having a category system. But you're a politician, you're welcome to do whatever you like. But you won't get us to sign that we agree with you. So he said, that's fine. Thought we'd ask. I thought, no, I'm not going to go down that rabbit hole, because you have to remain apolitical as a researcher as much as you can. Okay, now not all authorities agree about this. Okay, so for example, a study in the UK, they found no clear evidence of naming heat waves increased public concern or protective behaviour. Now, I don't know how bad the heat wave was. It might have got up to 35 or something, and these Brits are all, were just dying or something. I don't know, but this UK study didn't show there was any value whatsoever with it. And the study did actually involve Italy as well, which is Italy definitely gets heat waves. Controlled experiments with participants in England and Italy. So again, it was a controlled type study, naming a heat wave event, even with coming up with labels like Lucifer, heat wave Lucifer, had little impact on how people perceive risk or plan to respond. Now, maybe the Italians were just too busy drinking wine and eating yummy food, and the Brits were just too busy down the pub eating steak and kidney pies. I don't know, but it didn't seem to work in their study. But it's only one study, but nonetheless, it does show not everybody agrees. Now, the World Meteorological Organization, they haven't said we shouldn't do it, but they've expressed caution. While acknowledging heat wave poses a major growing public health threat, the organisation included naming individual heat waves could still shift focus away from critical messaging, namely who is at risk and what actions to take. Well, that quite contradicts what some of the other studies have shown. And I think they are just at the moment sitting on the fence. I don't think they're saying no. They just need more quantitative studies or more peer-reviewed research. And I say, is Australia different? And possibly it is. So these are some of my ideas for naming heat waves. That this has not been published. These are just ideas. I'm sure they're up for possibly a discussion. So first of all, heat waves are all about human health, but must also consider exposure of native wildlife, which we're responsible through our stewardship, livestock and crops, to high temperatures and prolonged heat. That is, they are necessarily place-based. So this is where some geography comes in. So for example, you may not name a heat wave in the Pilbara compared to Western Sydney, because in the Pilbara, well, it's just another summer's day. But under the current system, it'll still get picked up in the Bureau modelling as an extreme heat wave over the Pilbara. Well, there's a few mining companies up there, and they're in air conditioning from morning to 24 hours a day, you know. So even inside their vehicles, they're all air conditioned. Western Sydney, on the other hand, with its dense population, is a totally different situation. So this is where the geography comes in. It's very much about place. And I think you need a cut-off. So to have a heat wave, it needs to be very much above average. And I'm suggesting anything greater than 10. So the recent heat wave was up to 15 above average for areas that were affected by the heat wave, which I'll come to in a moment. And you'd base it on long-term regional data. So you need to have some kind of a threshold to actually name it. Otherwise, you just say we're going to have a moderate heat wave. You wouldn't give it a name because there isn't the urgency of a more severe heat wave or extreme heat wave. And I think it needs to be prolonged. So maybe it needs to, duration is pretty important. Now, this last one lasted 8 days in some places. That's pretty long heat wave. And they were quite populated areas as well, rural, regional areas. So maybe 3 days or more. And I think you need to have some exposure. So you need a medium to large population, must be exposed in the forecast heat wave, including metropolitan centres, larger regional cities and towns, but also agriculturally significant regions. So the Murray-Darling Basin was hammered quite badly by that recent heat wave. It's an important food bowl, and it would have some impact on cropping and so on. So I think you'd be thinking about that as part of your criteria. And obviously you'd be using the heat index, which we do at the moment anyway. So we bring in humidity and temperature, and maybe rethink the current 3 categories used by the Bureau: low intensity, severe, and extreme. So low intensity is usually yellow. Severe is a orange, I think, and extreme is red, which kind of makes sense. I'm not sure how they must have some cutoffs for deciding those. It must be based on the heat index, I think. Maybe coming up with categories like we do for cyclones, 1 to 5, something like that. Once again, these are just some ideas I'm throwing around. I'm sure there's lots of other things that people can think of as well. So let's have a quick look at these heat waves. Now, the first heat wave struck earlier in the summer, and we actually wrote that article back in early December, but they sat it, the conversation sat on it, waiting for a heat wave, which fair enough. So we made it a timeless thing, more or less, and they published it for this heat wave here. So that's why it picked up a bit of traction. Now, this is it occurred early in the month. Now, the attribution studies that were published on the Attribution Centre I showed you, that global site, they found that heat wave was 5 times more likely due to global heating. So an attribution analysis was done for that heat wave. And also that would have taken into account that it occurred during a weak La Nina, where there should have been generally a cooler condition. So the attribution would have taken that into account, plus the forcing of fossil fuel greenhouse gases in the atmosphere. So 5 times more likely, okay? And then, of course, we thought, oh, well, that's it for the summer. We can now move on and look forward. And then this really big one came along, and it affected a much larger area. It was more prolonged. And at that stage, the La Nina was in an even a weakening phase. There's been no attribution studies done for that heat wave, at least they're not published on that website. So you'd have to say, well, it has to be more than 5 times more likely. After that, you'd be speculating without doing the full analysis, but maybe 5 to 7 times more likely because of human-induced climate change, that heat wave, but definitely more than 5. Can't say it'd be less than 5 because we know it was a lot worse. The event peaked from the 24th to 27th, and temperatures exceeded 49 degrees Celsius in parts of South Australia, New South Wales and Victoria. And new 50 degrees Celsius shade temperature readings. This is not feels like temperature. This is just shade. It's not the heat index. Recorded in Andamooka, Port Augusta. Port Augusta's on the coast. And 49.8 at Marree, also in South Australia. So SA really copped it. And 49.7 at Pooncarie in New South Wales. Just to compare that with our records, the all-time official temperature records for Australia are Oodnadatta. I love that name. Oodnadatta on the 2nd of January 1960. That is linked to the 1959 El Nino event. So that was the natural forcing of the climate system made that, because back then there were much less much less greenhouse gases in the atmosphere. Well, 1960, there would have still been levels, but nothing like we have today. But it was a part of an El Nino event, and a decent one. And Onslow in Western Australia equaled the record on January 13, 2022. That's on the coast. And that actually occurred during a La Nina, but the western half of the continent behaves differently to the eastern half of the continent. So it's more likely to see heat waves during La Ninas, more likely to see cooler and wetter years during El Ninos on the other side of the continent. So only Eastern Australia that is a El Nino hotspot for drought and heat. So the West are different. We know that. They wanted to become a separate state. They're still thinking about it. Even their climate is different. Okay, so we're not far off that record. It's only a matter of time before we see that official record get broken, and it could occur this coming summer. We'll have to wait and see. So what caused the heat wave? Just wanting to finish off very quickly. It involved basically a big stagnant heat dome. You can see this from NOAA. This is showing temperature just as a color scale. And we stood out globally for this occasion. That big purple blob is the area affected by the heat wave, covering that massive area. Obviously, the core of that was the worst part. And it was actually an area of stagnant air. So there was a blocking upper high, was sitting a few kilometres above the surface, maybe 3-5 kilometres up, something like that. Not surface level, but higher up. Big upper high. High pressure system means descending air. It means no cloud, no wind, stationary, lots of solar energy coming in to heat the surface, and that energy being trapped there by all the greenhouse gases at night, remaining there and building up each day. So you get a build-up of heat from one day to the other. And that is the big killer with a heat wave. It's the fact that it builds up over a series of days because the whole air mass was stagnant, not going anywhere. So you get that clear skies and solar ingress. Analogy here is it acted like a pot lid trapping the hot air below inside the pot to form a heat dome. So the upper high is like the pot and all the hot air is trapped beneath it. But there was also some additional forcing going on as well, and that's why I put up the Hadley circulation. Around the same time, we had a tropical cyclone that came in over the Kimberley. It was a relatively weak one, and it dragged the monsoon trough down. It actually injected in the upper atmosphere additional energy into this heat dome in the form of latent heat, which is stored heat, in the form of water vapor. And as the Hadley circulation shows us, that air flows poleward and descended into around the latitude of the heat dome, around that 30 degrees south. That descending air, which started with the monsoon activity, descended. As it descended, it compressed, heated through compression, and it added extra energy into the heat dome. So there was the initial energy caused by the sensible heating just from the sun itself, making its way through that very clear atmosphere and no movement of that atmosphere, plus this additional energy from the, if you like, from the tropics in the form of latent energy, which is stored energy in the form of water vapor. That water vapor very quickly evaporated, of course, as that air descended. And as the air descends in the Hadley, the descending air, it compresses and heats, just like when you blow up a bicycle tire and you hold onto the valve, it'll be hot, won't it? You're compressing the air. So it's kind of a double whammy going on here that made it kind of worse than it might have been otherwise. So the descending air compressed into the upper high, adding additional sensible heating, compression down to the surface. Each day, some of the heat accumulated because not all of it escaped to space at night because it was trapped by all the greenhouse gases. And this exacerbated the intensity of the heat wave. So each day got worse and worse and worse. And for people who lived during this, they probably don't want to remember it. It's not the sort of thing that you want to remember. And eventually a cold front came through and moved it all out and broke it all up. So it was a very impressive event, but its anatomy is relatively well explained. It's not the first time this has happened. Not all heat domes are associated with upper high. Sometimes they're surface or blocking highs in in the Australia Bight, for example, or the Tasman Sea. This is just this particular peculiar heat wave involved this upper high and heat dome beneath it. Future heat waves, we do know they are going to become more common in a more carbon intensive future because we're on track to get as I said at the beginning, to get to 2.7 above pre-industrial. We're currently hovering around 1.5. And with that, we expect that shift I showed you in the curve, more extremely hot days and fewer extremely cool days. And days above 50 in Sydney and Melbourne, not necessarily on the coast, but mainly the inland suburbs, are very likely to be regular summer occurrences. Now, Penrith has already got to 49.5 at the foot of the Blue Mountains. They're quite a good rugby league team as well. Maybe they're just used to the heat. So, you know, it's already got close in Western Sydney as it is. So it'll become something more regular. We're talking 20 years from now, 25 years from now. And we're looking at days above 35. This is when the human body has a bit of trouble coping with heat. Obviously, when it's over 40, it's even worse. Is projected to be 3 times greater by 2070 compared to today in 15 towns and cities in Australia. So this is across the country. Bit of data for Queensland here. For Queensland local government areas, one study found heat waves would happen as often as 7 times a year, with events lasting 16 days on average. This is into the future. And that makes Queensland highly exposed because of its decentralised population, particularly compared to Adelaide and South Australia, for example. What we'd expect, though, is what's called these a risk for compound and cascading events. So while we might be looking at a heat wave, it could lead to multiple hazards or drivers occurring together in a sequence, thus compounding the impact. So a good example of that would be we have a drought, we have a heat wave, and then we get bushfires. So we've already had a drought to put up with, then we get a heat, that might last all winter, then we get a heat wave in the summer, and then we get a bushfires on top of that. So you're looking at this cascading or compounding effects going on. We need to prepare for that, not necessarily treat these as discrete entities because they often are related to each other. I won't go into this too much detail because we're getting a bit short of time, but we will need to think about adapting to climate change and heat waves in particular. There are different things we can do. We can look at avoiding certain places in the future that may simply be unsuitable for people to live in for most of the year. Parts of central and northern Australia stand out. We might think about how we can accommodate, gradually over time, accommodate through things like air conditioning, green infrastructure, white roofs, having more green zones in cities, all these kinds of things. Batteries in people's homes with solar, so they can run the air conditioning. So there is a power cut, they're running their own air conditioning and there's plenty of sun coming in during the heat wave, plus education. So there's a lot of incremental stuff that's already happening now. We can think about protecting ourselves in the future. So better building codes around double glazing, that's good for heat as well as for cold. And it's better to make it in the planning now rather than retrofitting later. And all the things that can happen in urban planning. And there's some very good ideas in that space out there. And finally, there's possibility of retreat later in the century. People will move. They will move from the north. This idea of populating the north that some areas of politics think is going to happen is actually a pipe dream. It's going to be too hot in many, not only will it be too hot for heat, but it'll also become uninsurable for things like cyclones and floods. So we could see retreat. So these are sort of things we're thinking about avoiding. Just don't go there or don't plan to live there. The second one is mostly what we're going to do. And we can also do a lot. This is where governments can play a role in terms of these protect things because they're more policy driven. And finally, retreat. Well, that depends on future greenhouse gas emissions. But I've heard that places like Darwin may have up to 250 days a year above 35 by the 2080s. And that's with the heat index making that even higher than that. So who wants to live in Darwin? And most of the year it's going to be too hot to really do anything outside. Should we think about naming East Coast lows? Maybe. And we've had some great examples of these historically. This is a very strong East Coast low. July 1st, 2025, you can see it sitting off the New South Wales coast there. It looks like a cyclone, doesn't it? Very tight isobars. A blocking high there as well. The high is actually cradling the low. I love that idea of cradling like a baby. Nonetheless, they can cause problems. Our most famous East Coast low was the Cygnus storm in 1974. This is actually, that's Manly in Sydney.
Oh, wow.
And Newcastle seems to have had a few of these because it was affected by the Cygnus storm, but also more recently in 2007 when the Pasha Bolka ended up on the beach in Newcastle. That was an East Coast low as well. So it might be worth thinking about naming the East Coast lows when they do occur, especially when they're like that one there. That clearly is a classic East Coast low that lasted for a few days. And that's it for me. Thank you.